In today's video, I brought you a very nice integral. It's set as I integral of natural log of x is multiplied by arc sine x dx. In fact, it's very interesting integral to work on, but it's a little tough because it's taking too many steps. So I'm going to give you some hints in order to solve this one. Here is a following hints which you can use as a tool. uv minus the integral of u dv. And the second hint, you have dk equals to un. If you have the derivative function of this one, you are looking for the primitive of this one. So you get this one equals 1 over n plus 1 is multiplied by u to the n plus 1. Here is the last hint. We have the sine of x equals 2 times tangent of x over 2 is divided by 1 plus tangent square of x over 2. Okay? Go ahead, pause this video if you would like to give that a try to this problem. When you worry, come back to see the full solution. Okay? Let's get into the solution now. So we have this integral I as natural log of x is multiplied by arc sine of x dx. It's very clear we are going to use the integral by parts by using the first tool. By setting du equals natural log of x and v equals arc sine of x. Okay, we have a du equals natural log of x. If you have du equals natural log of x, I'm looking for the primitive of this one. I will have u equals integral of natural log of x dx. Okay, by putting dk equals to 1 and l equals natural log of x. Okay, so by applying the by parts here, I will get natural log of x. I will get integral of natural log of x dx equals the primitive of this one is x is multiplied by the natural log of x minus the integral of the primitive function of number 1 is x is multiplied by the derivative function of natural log of x, which is 1 over x dx. So by simplifying x, I will get x is multiplied by natural log of x. I will have minus integral of dx, which is x. So I will have minus x here. This one is giving me x is multiplied by natural log of x minus x. So I'm going to tick off all of these things. Now I'm going to apply the by parts on this one now. So we'll have I integral equals this as the original function. X is multiplied by natural log of x minus x is multiplied by arc sine of x minus the integral of this one, which is x is multiplied by natural log of x minus x and is multiplied by the derivative function of arc sine, which is 1 over square root of 1 minus x squared. So this one is giving us square root of 1 minus x squared dx. So I'm going to call this one as a capital A. So we'll have I integral equals capital A minus. Now I'm going to split this integral into two integrals. I will get the first integral minus x is multiplied by natural log of x over square root of 1 minus x squared dx plus another integral minus is multiplied by minus is giving us plus integral of x is divided by square root of 1 minus x squared dx. Okay, so I'm going to calculate each integral separately by starting with the I1 integral. So I1 integral equals x is multiplied by natural log of x is divided by square root of 1 minus x squared dx. So I'm almost doing the same job. This time I'm going to set dk as x over square root of 1 minus x squared and v as natural log of x. So we'll have dk equals x over square root of 1 minus x squared and v equals natural log of x. So here I will have dv equals 1 over x here by looking for the primitive of this one. I'm going to use a trick here. So this one is written on this form. I'm going to bring this square root of 1 minus x squared to the denominator. It become x is multiplied by 1 minus x squared to the minus 1 over 2. Okay, so this one, it will be written on this form. 1 minus x squared prime, like this, is multiplied by 1 minus x squared to the minus 1 over 2. If we try to derivate this one, is giving us minus 2x, but we have only x here, so we need to multiply by minus 1 over 2. Okay, now I'm going to use this tool that I have here. If you have dk equal to u to the n, the primitive function of this one is giving us 1 over n plus 1 is multiplied by u to the n plus 1. So in this case, we have n as a minus 1 over 2 plus number 1. On the multiplier, we have 1 over n plus 1, which is 1 over 1 minus 1 over 2. So this one, by looking for the k, is giving us minus 1 over 2. The original one is multiplied by 1 over 1 minus 1 over 2. Okay, as we have here, 1 over n plus 1 is multiplied by 1 minus x squared to the 1 minus 1 over 2. Okay, so 1 minus half is giving us half. 1 over half is 2. 2 is multiplied by half is giving us 1. With this minus sign, we'll have minus 1 is multiplied by this one. This one is 1 minus x squared. So to the 1 minus 1 over 2. 1 minus 1 over 2 is half. So is half is same as the square root of this one. Okay, so this is k. I'm going to apply by part. By applying this one, uv, which have k is multiplied by v. So we'll have natural log of x is multiplied by k. I will have minus square root of 1 minus x squared is multiplied by natural log of x minus the integral of u dv. So u with this minus sign become plus square root of 1 minus x squared is multiplied by derivative function of a natural log of x, which is 1 over x. Okay, dx. So it's giving me this one. What I'm going to do now, I'm going to plug this expression into I1 integral. Then I'm going to bring this I integral expression at the top in order to make the work clear and not get lost, because we have a lot of calculation here. Okay, this is I integral. We have this capital A. This is capital A minus I1 integral, which is this one. With this minus become plus square root of 1 minus x squared is multiplied by a natural log of x minus this integral, which is minus integral of square root of 1 minus x squared over x dx plus I2 integral plus this one plus integral of x is divided by 1 over minus x squared dx. Okay, I2 integral, let's put this one as a prime term. Okay, the whole thing plus this 2 integral. Now let's call this one as a I3 integral. So now we don't need this information, just I'm going to start from here to here. Now I'm going to calculate I3 and I2 as we starting from the beginning. Okay, at the end of the term I'm keep plugging all those information into that expression. Okay, for I2 integral equals x is divided by square root of 1 minus x squared dx. This is very simple as we did before. This one is giving us the integral of x is multiplied by 1 minus x squared to the minus 1 over 2. So dx, this one we already calculate this one, it was minus 1 minus x squared to the 1 over 2. Okay, so we already calculate this one, it was this one. This one is giving us 1 minus x squared as a primitive. So this one we already calculate this one. So this one is, I can't change it on the form of square root like this, 1 minus x square. Now we're done with this one. So here I will have this term, I will have minus square root of 1 minus x square. Okay, so we don't need this one now. Now I'm going to calculate I3. So I3 integral equals square root of 1 minus x square over x dx. So now it's very clear, since we have the square root of 1 minus x square, so this one is written on the form of sine square x plus cosine square x equals 1. So by putting the substitution of x equal to sine of theta, we are going to find out this. Set sine of theta equals x. That means dx equals cosine theta d theta. Okay, so this one will have I3 integral equals, by replacing sine theta into the square root, it will have 1 minus sine square theta is divided by sine theta dx, it will be replaced by cosine theta d theta. Okay, so this term it will be replaced, so the inside of the square root will be replaced by cosine square theta. By taking the square root off from here, by taking the square root out of here, it will be left with absolute value of cosine theta. Okay, so if you have cosine theta is positive, we are going to keep positive number. If cosine theta is negative, we are going to take the negative sign. Okay, but since we have the integral here and the primitive, since we have the integral here, so we are going to keep the positive term. Okay, only, so we don't need a negative to be here. So this integral become cosine theta is multiplied by this cosine theta, which built from the derivative function, is divided by sine theta. Okay, d theta. So cosine theta, we don't need to put the extra term here, so simply we are going to put the square here. So now I'm going to, in order to evaluate this one, I'm going to use a trick. So by switching cosine square theta by 1 minus sine square theta, so I will have I3 integral equals 1 minus square theta, 1 minus sine square theta is divided by sine theta d theta. So I'm going to split this integral into two integrals. I will have first integral d theta is divided by sine theta. Second integral, I will have minus sine square theta over sine theta. So by simplifying by sine theta, I will have minus sine theta, my integral of sine theta d theta. This one is turned to the minus cosine theta. Okay, so we'll have I3 integral equals d theta is divided by sine theta plus, with this minus sign with this minus become plus cosine theta. Okay, is already calculated this one. So I need to calculate this term. This one is tricky. We are going to use a trick in order to find out this one. So now I'm going to use the third tool, this one. How this one goes here. So I'm simply going to replace sine theta by this term, but I'm taking the inverse of this one. So by taking the inverse of this one is giving us I3 equals 1 plus tangent square theta over 2 is divided by 2 over tangent 2 is multiplied by tangent theta over 2. Okay, so by taking this half outside of this integral d theta, now I'm going to do a nice substitution here by replacing tangent theta over 2 with t. So we'll have t equals tangent theta over 2. By taking the differentiation of this one, it's giving us dt equals half is multiplied by 1 plus tangent square theta over 2 d theta. So we'll have by multiplying both sides by number 2, we'll get 2 here, we'll get 2 here. We'll have d theta equals 2 is divided by 1 plus tangent square theta over 2 dt. Replacing tangent theta over 2 with t, I will have 2 is divided by 1 plus t square dt. So I'm going to plug all this information into this integral. Is giving me half is multiplied by the integral. I will have 1 plus t square is divided by t is multiplied by this term, which is 2 is divided by 1 plus t square, all is multiplied by dt. So I will have a nice cancellation here. So this 1 plus t square will be cancelled out with 1 plus t square, and this number 2 will be cancelled out down to the number 1. So I will have the expression of dt over t. This one, it's very clear, is a natural log of t, which is natural log of absolute value of t. So I'm going to bring this one to the original substitution, which was tangent theta over 2. So we'll have natural log of absolute value of tangent theta over 2. So again, the original substitution was x, okay? So now I'm going to replace theta with arc sine x, okay? I'm going to clean up this one. We'll have I3 integral equals natural log of tangent half is multiplied by theta will be replaced by arc sine x. We'll have arc sine x here with absolute value here plus this term. What I'm going to do plus cosine theta here, okay? Because this one, it was just this one plus cosine theta term. So cosine theta will be replaced as well with that term right here. So I will have cosine of arc sine of x. This term is already calculated. We don't need it here because it was replaced with this one here. Now I'm going to bring this I3 integral up here and calculate I integral. Now I'm going to plug I3 integral with its value, then calculate I integral. Now I will have a final expression of I integral x is multiplied by natural log of x minus x is multiplied by arc sine x plus square root of 1 minus x square is multiplied by natural log of x minus square root of 1 minus x square plus I3 integral, okay? Plus natural log of plus cosine of arc sine x plus constant c, okay? Here is a nice expression. Now we have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you next video. Bye.